Today's session we will do some problems based on electromagnetic induction. Now in the last session we have learnt about Faraday's law of electromagnetic induction and also about Lenz's law. Based on Lenz's law we will take one or two problems. First you take down this question. Figure shows planar loops of different shapes. Planar loops of different shapes moving out or into a region of magnetic field. Moving out or into a region of magnetic field. Which is directed normal to the plane of the loop. Which is directed normal to the plane of the loop away from the reader. Determine the direction of induced current in each loop using Lenz's law. Determine the direction of induced current in each loop using Lenz's law. Now first you take down the figure also. As a cross magnetic field, that means the field is going into the plane of the paper. First we have a rectangular loop. And let us say this loop is moving into the field. A, B, C, D. Now say I have a triangular loop moving away from the loop, and then some irregular shape. It's also moving away from the field. Figure shows planar loops of different shapes moving out or into a region of magnetic field which is directed normal to the plane of the loop away from the reader. Determine the direction of induced current in each loop using Lenz's law. Now we know, according to Lenz's law, the direction of induced EMF is such a way that it opposes the very cause producing it. Now in each case we have to find out why there is an induced current. What is the cause for induced current? Now we'll write solution. Consider the first loop. It is moving into the magnetic field. So first loop, or rectangular loop. So this loop is moving into the field. Now when it moves into the field, what happens? The field lines which cuts along the loop increases, or there will be more cross fields which is linking the loop, and this, due to this change in cross magnetic field linking the loop, any EMF gets induced or a current starts flowing in the loop. Now what should be the direction of current induced? The direction of current should be in such a way that it opposes the very cause producing it. The cause here was the increase in the cross magnetic field, because when the loop is moved into the field, the cross magnetic field will increase. Now for example, just in case, like now when the loop is here, it is cutting only one cross according to this figure, but when this is moved into the field, I'll just draw some more lines. So when it is moved into the field, it will have more number of magnetic fields. The same loop, it's not rectangular in shape, but it should be in rectangular in shape. Same loop moved into the magnetic field, the cross magnetic field will increase. Cross magnetic field which is linking the loop will increase. Now the current should reduce this increase in magnetic field. That means now we have cross, so to reduce this, the current should produce a magnetic field which is opposite to this. That means it should produce dot magnetic field, or the field lines which are coming towards us, or moving away from the plane of the loop. So to get dot magnetic field, what type of current we should have, whether clockwise or anti-clockwise? So if you can recall, in the previous chapter we have learned that when we have a circular current loop, and if the current is in the anti-clockwise direction like this, then we have a dot magnetic field, and if we have a circular loop with current going in the clockwise direction, then we will have a cross magnetic field at the center. Here also dot magnetic field at the center. Now we need to, the loop current should produce a dot magnetic field, therefore current should flow in the anti-clockwise direction like this. So in the first case, the current produced is in the anti-clockwise direction. Now what happens in the second case? Like we'll take this triangular loop. Triangular loop. Now consider the triangular loop, it is moving away from the field. Now what happens when it is moved away from the field? When it moves away from the field, the cross magnetic field reduces, or the field lines which are the loop links reduces. The flux linking the loop reduces. The current induced must oppose this. That means it should increase the field down. Now when the loop is moved away from the magnetic field, the cross magnetic field has reduced. The current should increase the cross magnetic field, therefore current produced should be in the clockwise direction. Why? Because we know to increase cross magnetic field we should have a clockwise current. When the loop is moved away from the magnetic field, the cross magnetic field reduces. To increase this, we should have a clockwise current, therefore in the triangular loop a clockwise current is produced. Now again in this irregular shape, it is same as this triangular loop. The loop is moving away from the cross magnetic field, and to increase this field, when it is moving away from the field, the cross magnetic field which is linking the plane of the loop reduces. To increase this, we should have a current which will produce cross magnetic field. So the loop current must be now in the clockwise direction. This is how we have to apply Lenz's law to find out the direction of current. Just make a note. First you should understand whether the magnetic field is increasing or decreasing, and you should know the type of the magnetic field also, whether it is cross or dot, and you know the meaning of cross and dot. The cross magnetic field means it is directed normal to the plane of the loop, and dot means it is moving away from the plane of the loop, or going it is coming towards us. Cross means it is going away from the reader, dot means it is coming towards the reader. In case in this case, first loop, the current is due to the increase of cross magnetic field. To reduce that, we should have a current which will produce that dot field. That is why the current produced is in the anti-clockwise direction. It is opposite in these two cases. A clockwise current is produced to increase the cross magnetic field, because the loops are moving away from the field. The cross magnetic field reduces, and hence to increase this we should have a clockwise loop current. We'll take some more problems in the coming classes.